All right, this is the pre-video for Math 201 Brief Calculus for day one of week one. We're going to be looking at some review from algebra and starting with graphs of equations and looking at how to sketch the graph of an equation. So when you want to sketch the graph of an equation and you don't really specifically know the shape of the equation's graph or where exactly to start if you have no other basic background information, you can start with something called a table of values. So a table of values is where you would list x values that you're going to plug into the equation, and you plug them in and solve for the y values. And that pen is very thick, so let me fix that. Okay, so for example, if you know nothing about the equation, you can always start with the standard -2, -1, 0, 1, and 2. So we plug them into the equation and work them out. So 2 times -2 would be -4, minus 1 would be -5. 2 times -1 would be -2, minus 1 would be -3. 2 times 0 is 0, minus 1 would be -1. 2 times 1 is 2, minus 1 would be 1, and 2 times 2 is 4, minus 1 is 3. Now, some of you may be familiar with this equation. It's a linear equation. A linear equation is one where you have an x and a y, or either variable. It doesn't have to be both, but they're only raised to the first power, and there's no radical symbols or absolute value symbols or anything weird like that. It's just numbers and variables. So what this is going to be is this is going to be a straight line when we plot it. So we're going to plot this. So -2, remember to plot points, you start at the origin 0, 0. If the first number tells you to go left or right, and the second number tells you to go up or down. So this is left 2, down 1, 2, 3, 4, 5. We'll put a dot there for the point. And then we have -1, -3. So left 1, down 1, 2, 3. And then 0, -1. So that's no left or right, but down 1. Right 1, up 1. And then right 2, up 3. So you notice all 5 of those points are in a straight line together. And you'll want to connect them, and we put arrows on the end because this does not stop. This equation is good for any ordered pair that fits that relationship. Um, there are other ways to graph that. Linear equations can be graphed using the slope-intercept form, which is what it's already in. So we'll talk about that in one of our other videos. For y equals x squared minus 4, that one is going to be a parabola because the highest power is x to the second and y is still to the first power. But again, if you did not know that or you didn't know where to start, you would start out with your -2, -1, 0, 1, and 2. Plug them in. Now you have to be careful here because you're plugging in a negative into something that's being squared. So you square this, and that means -2 times -2. So that's +4 minus 4, which would be 0. -1 squared would be 1, minus 4 would be -3. 0 squared is 0, minus 4 is -4. 1 squared is 1, minus 4 would be -3. 2 squared is 4, minus 4 is 0. So again, we're going to plot the points. So -2, 0 is an x-intercept. We're going to formally define that in just a second. -1, down 3. 0, -4 would be no left or right, then down 4. 1, -3, and 2, 0. And notice this is a U-shaped graph, best that I can draw. And that is a parabola. Okay, so the question becomes, is there ever a reason to not use -2 to 2? And the answer is yes, there are certain times where we would not want to use that as our setup. So for example, this is an absolute value equation here because it has the absolute value symbol. But notice there's something inside the absolute value symbol with the x. Before, when we had x squared up here, notice it was just an x squared. The -4 was not being squared. So anytime something is inside within the symbol, it's going to shift your table. You don't want to start with 0 being your center. So if you're dealing with something like this, the center of your table always needs to be whatever makes this inside part equal 0. And this will help you get nice, consistent graphs. So if you set that equal to 0 and solve it, it's -1. So we need to center our table to the left of 0, essentially at -1. Then we'll pick two numbers smaller and two numbers larger. So notice this is -3 to 1 now. If you did -2 to 2, you'd still get the graph, but you wouldn't have the center of the graph at the center of the table. And that sometimes causes problems if you don't get enough information, because this graph does something interesting. So let's plot out these points. So let's see, we have, and this is absolute value. So -3 plus 1 is -2. Absolute value makes that positive because it measures distance. So that would be 2. -2 plus 1 is -1. Absolute value of that would just be 1. -1 plus 1 is 0. Absolute value of 0 is 0. 0 plus 1 is 1. Absolute value of 1 is 1. 1 plus 1 is 2. Absolute value of 2 is 2. So we get left 3 up 2, -2 up 1, -1 0, 0 1, and 1 2. Notice this graph has a V shape. Absolute value is a V-shaped graph. And if we didn't get the right set of points, we might miss this little turning point here. And say you'd only graph some points over here, you would think you have just a straight line. So it's very important to center that table if you can. Now, the last one that I picked for the graphing ones is that this one is a square root of x minus 2. So again, there is a centering issue here. This is going to be centered at x minus 2 equals 0 would be x equals 2. But there's another problem with this graph. If you put it at the center of your table and you pick something smaller and something larger, what you'll notice is when you plug in 0, you'll get 0 minus 2. That is the square root of -2. That is imaginary. We can't use that. Imaginary numbers are not on the real axis. So this is not going to work, and neither is this. So the rule with radicals is you need it to be greater than or equal to 0 when it's an even root. If it was an odd root like a cubed root, we would be okay, because you can take a cubed root of a negative number. That's because that's 3 negative numbers multiplied together. So with this, you have to be very careful. So we want to make sure we don't plug anything that makes anything imaginary. So we might need some more points like 5 and 6, since we didn't have the ability to use these two because they were undefined for us. Okay. So if we plug in 2, that's 2 minus 2 is 0. So square root of 0 is 0. 3 minus 2 is 1. So square root of 1 is 1. 4 minus 2 is 2. So we can't take the square root of 2 without using a calculator. 5 minus 2 is the square root of 3. And 6 minus 2 is 4. Square root of 4 is 2. So I didn't write in all my square roots here, but you can go back in if you want to. So we're only going to plot the 3. As long as we have 3 good points, we're good for the graph, because these you'd have to use your calculator to estimate. So 0, 2, 0 was our first point. So right 2, up or down, none. And then we had 3, 1. And then we also had 4, 5, 6, 2. Those were all nice points that happen on the grids. So notice that a square root function or equation here is on its side, and it kind of looks like half of a parabola. Okay. The other thing I want to cover in this section, 1.2, is how to find intercepts, because this is, again, an algebra skill from a previous course. So first of all, we have to know what an intercept is. An intercept is points on a graph that intersect either the x-axis or the y-axis. And so notice this picture, there's no x-intercept, but there is a y-intercept here. This one has 3 x-intercepts, but this origin is also a y-intercept because that's where the graphs intersect each other. And then 1 x-intercept here, 2 y-intercepts, and then this one has no intercepts because it's not crossing either the x or the y-axis ever. So that's how you would tell from a picture. You just pick those intercepts out, but we're usually not going to have a picture right in front of us. So we want to be able to find x and y intercepts algebraically. So to find the x-intercepts algebraically, you let y be 0 and solve for the equation for x. So what that means is because x-intercepts look a certain way, x-intercepts are always a number, comma, 0. Let me redo that. That is a little too... keeps wanting to make the ink really thick, which is annoying. This is a number, some number, a, comma, 0. That's what x-intercepts look like. And y-intercepts always look like this. They're always 0, comma, a number. So to find the intercept, you always want to plug in 0 for the opposing or opposite letter, the one that you want to get rid of, essentially. So we're going to start this off. I'm going to find the y-intercept first because that's usually easier. So to find the y-intercept for this one, we're going to plug in 0 for all the x's. So y equals 0 squared minus 2 times 0 minus 3. So that would be 0 minus 0 minus 3, or negative 3. Now, you do not just write negative 3 or y equals negative 3. An intercept is an ordered pair. So the y-intercept for this first one is 0, negative 3. Now we're going to find the x-intercept for this graph. Now, it could be plural sometimes. Just depends on what the graph does. So this one we plug in 0 for the y. So notice this time it's a little different to solve this. The first one, you just evaluated it. You just plugged it in and worked it out. This is now a quadratic on this side, which is an x squared equation, and we need to solve it by factoring. So we're looking for two things that multiply to negative 3 but add to negative 2, since this starts with a 1x squared. So I'm thinking negative 3 and positive 1. We can FOIL this back out and check. This would be x squared plus x minus 3x would be negative 2x, and minus 3 times 1 is negative 3. Then we set each of these individually equal to 0 and solve for each x. Now I'm going to be posting on the YouTube channel a video of factoring review. So if it's been a while since you took Math 136, or you tested into this class somehow and didn't take Math 136, then you will want to probably brush up on your factoring sooner than later. So this is 3 and negative 1 were two separate x values that we found, and the y value both times is 0. So there are my intercepts for number 1. So let's do number 2. Sometimes it is easier if you go ahead and solve the 6 over. Just makes it easier to plug in and solve for each of the x and y. So we'll add that 6 back over. So let's do the y-intercept first again. So if I plug in 0 for x, that would be minus 3y equals 6. That's just going to be negative 3y. Watch your sign. Make sure you don't lose that. Equals 6. We'll divide by negative 3, so we get negative 2. So this is the ordered pair, 0, negative 2. For the x-intercept, we're going to put 0 in for y. And then this would be 4x equals 6. Divide by 4. We want to reduce that fraction and make it 3/2, because top and bottom are both divisible by 2. So this would be 3/2, comma 0. Okay, so we've reviewed how to graph using a table of values, and we've reviewed what are intercepts and how to find them algebraically.